filtration, wastewater treatment, and chemical, metal, and water resource recovery recycling system, Econoback System. SANSHIN MFG Company Limited was quick to tackle the environmental business aimed at electroplating and forged ahead with the development of systems and equipment based on recovery and recycling. Based on our fundamental policy of save everything, clean everything, we have constructed systems through the efficient combination of purification, chemical recovery, and rinse water circulation. We announced our Econoback system in 1971. Refiners, such as filters used to extend liquid life and improve quality on plating lines. Evaporators, used to enable the recovery and reuse of plating chemicals and water. Ion exchange units used to recycle final rinse water. The Econoback system embodies the very principles of SANSHIN. In 1973, SANSHIN founder Yoshiteru Yagishita stated in the foreword to the Journal of the Metal Finishing Society that the starting point of pollution control lay in the closure of industrial waste, and spoke further on the importance of natural resources and circulation, again in 1980. This pioneering way of thinking and subsequent initiatives on resources and recycling paved the way for the construction of the current Econoback system. Let's now take a look at the basic system configuration of the Econoback system. The standard plating process involves going through a pre-treatment process where degreasing and acid rinse are performed, a plating process used to improve surface quality based on the application, and a rinse process used to rinse off plating chemicals adhering to materials and then heading to the next process. In the pre-treatment process, a treatment bath is purified with a filter and oily water separator to extend the life of the bath fluid. In the subsequent plating process, plating chemicals are purified with a filter and activated carbon treatment while exercising strict control over both temperature and humidity, thus extending the life of plating fluid and ensuring stable quality. Furthermore, plating chemicals dipped in a rinse tank are condensed, and plating solution, as well as copper and chromium contained in the solution, are recovered and recycled using an ion exchanger, and so on. In the rinse process, all metals and water are recovered with an ion exchanger, etc., in an effort to reuse rinse water. Wastewater from each process is detoxified with a wastewater treatment equipment and then discharged outside the system. Furthermore, all metals are separated and recovered from cylinder-type ion exchanger regeneration elution at our resource center and are then recycled at the smelting plant. SANSHIN aims to provide an ultra-compact environmental load treatment system capable of recycling and resource recovery at low cost. The Econoback system is comprised of 6 major processes: degreasing, acid rinse, plating, recovery, water rinse, and resource recovery. At the degreasing process, oil and suspended solids content mixed in solution are separated by degreasing bath oil separation units, Filtrata OOZ, and Filtrata OOY. At the acid rinse process, acid solution containing metal is separated into metal salt and free acid, and metal salt is discharged by acid and metal salt separators, reciter and econometry. The plating and recovery processes enable the effective use of plating solution and recovery solution, and this is achieved with evaporators Conry Clean and long tube vertical evaporator. At the plating process, suspended solids content in the plating solution is removed to extend solution life and reduce plating defects by clarifying filters Eco Ace Plus and Model SYL. At the water rinse process, water is circulated and water is saved from the day the equipment is installed, facilitating valuable metal recovery and contributing to resource recovery with cylinder-type ion exchangers, Regeneration System Patrone I, and on-site regeneration system Econoselfie. And finally, SANSHIN employs a resource center system to recover and recycle resources such as water and metals, providing total support for your initiatives to ensure effective use of limited resources and resolve environmental issues. Our closed-type atmospheric evaporator, Conry Clean, was developed to save resources, save energy, and reduce the environmental load at surface treatment processes. The closed-type Conry Clean has the following features. It discharges no mist or vapors outside the system, meaning no environmental contamination. Compared with open-type atmospheric evaporators, concentrated solution is not contaminated with dust in the air. And evaporation occurs at low temperatures of between 35 and 55 degrees Celsius, making it applicable even for liquids containing constituents that decompose at high temperatures. Because it uses circulating air in the evaporation media within a closed system, no carbon dioxide gas in the atmosphere is absorbed. And it recycles high-purity condensate water not recovered with open-type evaporators as rinse water to realize a closed plating line. Conry Clean is composed of evaporation and condensation sections, each of which is connected with an air duct, and air is circulated with an axial flow fan. Firstly, the raw solution to be concentrated is introduced into the evaporation section. Next, the raw solution is heated with a heat exchanger until the evaporation setting temperature reaches 35 to 55 degrees Celsius, and then it is sprayed. By doing so, water in the raw solution evaporates as steam. Moist air containing high-temperature steam is then sent from the evaporation section to the condensation section. The high-temperature moist air is cooled with a heat exchanger. Accumulated low-temperature condensate water is sprayed into the air, lowering the air temperature, and water content that can no longer be contained is removed as condensate water. In this way, our closed-type atmospheric evaporator, kindly clean, employs a principle whereby the amount of saturated steam in the air increases as the air temperature rises and decreases as the air temperature falls. Condensate water built up in the condensation section is drawn into the condensate water tank, allowing it to be reused as rinse water. Concentrated solution concentrated in the evaporation section is concentrated until the target concentration is reached, allowing it to be recovered and used as pre-treatment liquid or plating solution. Air in the evaporation media circulates through the evaporation and condensation sections in the closed system, and by continuously evaporating raw solution at the evaporation section and condensing evaporated steam at the condensation section, high purity concentrated solution and condensate water can be recovered. Next, let's take a look at the water rinse process. The water rinse process is used to rinse off chemicals and contaminants adhering to the surface of goods coming out of the processing liquid tank with water, and then hand them over to the next process. The more water is used, the cleaner the goods will be. However, the water used is a costly and precious resource. In order to reduce the amount of rinse water and wastewater after rinsing, a multi-stage counterflow water rinse system is effective. What's more, water can be recycled and saved by installing the cylinder-type ion exchanger Patrone I in the final rinse tank. Let's take a look at an application example inside the water rinse process of the cylinder-type ion exchanger Patrone I. If Patrone I is not installed, a significant amount of water is required to maintain the water quality in the final rinse tank, increasing the wastewater treatment load. By installing Patrone I in the final rinse tank, in addition to significantly reducing the amount of supply water used, water quality in the final water rinse tank is always stable, customer product quality is improved, and the environmental load is reduced. Let's now take a look at the Patrone I desalination method using an ion exchange resin. The Patrone I cylinder contains both cation exchange resin and anion exchange resin. The raw water in the final rinse tank flows into the cylinder with cation exchange resin, and an ion exchange reaction occurs between the raw water and cation exchange resin. The raw water then flows to the cylinder with an anion exchange resin, and an ion exchange reaction occurs between the raw water and anion exchange resin. Pure water treated and purified through the ion exchange reactions inside the cylinders returns to the final rinse tank to be reused. Let's take a look at the cylinder-type ion exchanger Patrone I. Patrone I recovers metals and rinse water from surface treatment processes such as plating, based on the basic concept of protecting our precious metals, water, and energy to contribute to the improvement of our environment. The main features of Patrone I are that water can be circulated immediately after installation, significantly reducing the amount of water used and costs. Burdens on wastewater treatment equipment can be reduced. And saturated cylinders are regenerated at our resource center, allowing them to be reused repeatedly. 25, 50, 100, and 200-liter capacity cylinders are available, and various combinations can be selected based on the line scale and liquid type. In addition to the Patrone I regeneration system, SANSHIN offers a comprehensive lineup catering to customers' requirements, including the on-site regeneration system, Econoselfie. Let's now take a look at the resource recovery process. SANSHIN's Resource Center system is used to collect metals, chemicals, water, and energy disposed of at each line to realize resource recycling with a centralized individual recovery process. Plating wastewater-related accidents became more frequent as the Japanese domestic industry expanded during a period of high economic growth. The Water Pollution Control Law was enforced in July 1971 in order to strengthen wastewater regulations. As a result of this, SANSHIN's existing research involving industrial experiments on plating wastewater treatment for the recycling of both chemicals and water was designated as the Ministry of International Trade and Industry's Important Technological Development Issues in fiscal year 1971. Through this research, the concept of regeneration utilizing our announced cartridge-type ion exchanger led to the completion of the portable Patrone system, resulting in the development of a closed system for the subsequent plating process and establishment of the Resource Center. In April 1976, we established the Resource Center at our Inuyama factory and began sales of the cylinder-type ion exchanger, Patrone I, and launched our regeneration business. At the Resource Center, cylinder-type ion exchangers are periodically collected from plating plants, and heavy metals are classified by type to enable recycling as precious metal raw materials. Furthermore, cylinder-type ion exchangers are cleaned and regenerated before being returned to customers again to allow repeated use. We regenerate over 6,000 cylinder-type ion exchangers for our customers throughout Japan each year, and to date have regenerated over 180,000 exchangers in total. Beginning with the Tokai Chemical Industry Association Award in 1983, we have been recognized as an outstanding business in the fields of resources and environmental load, and have since been honored with a variety of awards, such as the 2007 Aichi Environment Award Silver Prize for our Resource Center system. In April 2010, we received Fiscal Year 2009 Pioneering and Efficient Recycle Business Certification from Aichi Prefecture and also started a high-functionality resource recovery system business. And in 2012, we received awards such as President Prize of the Japan Environmental Management Association for Industry at Resources Recycling Technology System Awards Ceremony. With our chromic acid recovery system, we were able to concentrate and purify chromic acid elution to acceptable resource recycling reference values, and also developed a system whereby nickel and copper that were previously converted to sludge and recycled at the smelting plant could be recovered and recycled as metal foil with roll-type electrodeposition equipment in our resource center. Through this, we were able to achieve improvements in resource recovery efficiency and reduce waste. Let's now take a look at the flow of our resource center system business. Our cylinder-type ion exchanger, Patrone I, is filled with ion exchange resin to suit the application and is then installed in the final rinse tank. By circulating rinse water, heavy metals adhere to the ion exchange resin. By continuing with circulation, the ion exchange resin becomes saturated, preventing the required water quality from being obtained. Saturated cylinder-type ion exchangers are taken to the resource center where the cylinders are cleaned and ion exchange resin is regenerated. Cylinder-type ion exchangers collected from customers are classified according to application and the process at which they are used, and are then transferred to the regeneration process still filled with ion exchange resin. At the regeneration process, adhering heavy metals are separated from saturated ion exchange resin using regenerant. Elution containing heavy metals is then transferred to the resource recovery process. A performance inspection of ion exchange resin is conducted on regenerated cylinder-type ion exchangers before returning them to customers to be reused. SANSHIN's regeneration business employs an individual regeneration system to ensure that ion exchange resin does not become mixed with that of other customers. With the mixed regeneration systems employed by other companies, resin becomes mixed with that of other customers and is regenerated altogether, creating a risk of good resin being mixed with degraded resin or contaminated with impurities. At SANSHIN, the condition of customers' resin, the frequency of regeneration, and the level of degradation are all managed with individual regeneration. Understanding the condition of our customers' resin allows SANSHIN to notify our customers when resin has to be next regenerated or replaced. This system ensures use of resin with peace of mind. resource recovery of effluent containing heavy metals generated at the regeneration process is carried out for each metal. Here we will look at copper and nickel recovery. The pH of all separated and recovered elution is adjusted, and then the elution is collected as metal with roll-type electrodeposition equipment. The collected metal is of extremely high purity and is transported to the refinery where it is reused as raw material. Elution containing chromium is concentrated with our chromic acid recovery system and is then transported to the refinery as high concentration chromic acid where it is reused as raw material. Through our resource center system business, SANSHIN contributes to the recycling of over 500,000 tons of water resources and valuable metals on a global scale annually and supports the stable operation of our customers' processes and promotes sustained quality improvements. Filtration, wastewater treatment, and recycling. SANSHIN proposes the Econoback System comprising these three technologies and product groups to continue to respond to the increasing requirements of our customers.